Section 3.7, equations of lines in the coordinate plane. Slope m of a line is the ratio of the vertical change rise over the horizontal change run between any 2 points. So slope is rise over run or vertical change over horizontal change. To find the slope given 2 points x1, y1 and x2, y2, we use our slope formula, which is y2 minus y1 over x2 minus x1. If you're given a diagram, you can also count the rise and the run and create a fractional representation of the slope. Find the slope of the line passing through the points 4, 6, 8, negative 2. So we've got x1, y1, and x2, y2. So our slope formula, y2 minus y1 over x2 minus x1. So that means we're going to take negative 2 minus 6 over 8 minus 4. On the top we have negative 8, on the bottom we have 4, so our slope is negative 2. The slope-intercept form of a line of an equation of a non-vertical line is y equals mx plus b, where m is the slope and y is the y-intercept. Point slope form of a line is given by the formula y minus y1 equals m times x minus x1, where y1 is one of the y coordinates for a point and x1 is the x coordinate of the same point, and m is your slope. So here we want to graph using slope-intercept form. So to do that, we should recognize that our slope is 2, and our y-intercept is a positive 3. So we plot our y-intercept first at 3, and we apply our slope. Up 2, right 1. Now that we can't go any farther, we'll go backwards. Down 2, left 1. Down 2, left 1. And so our line looks like this. Question 2, same idea. Our slope in this case is negative 3/4, and our y-intercept is negative 1. So we put our point at negative 1, and we apply our slope. Down 3, right 4. To get the rest of the line, I'll do the opposite from my starting point. I'll go up 3, left 4. And now I'll just connect my points to draw my line. This time we want to graph using point slope form, which is a little more tricky, but still doable. So remember, this is our slope. But this time, with point slope form, we have an x1 and a y1 value embedded into the problem. So the point they actually gave us to start with is the point 3, negative 2. And so we're going to plot that point first. 3, negative 2 here. And we're going to apply our slope. Down 1, right 2. Then I'll get the rest of my line. Up 1, left 2. Up 1, left 2. Up 1, left 2. Up 1, left 2. Then we just connect our points, and there's our line. You could have also rewritten this equation by distributing the slope and bringing over the 2 and put it in slope-intercept form and tried graphing it that way. So graphing the second example, I'm going to graph it the same way I did the first one. I know my slope is 2, and I'm starting with the point negative 4, 2. So negative 4, 2 is here. My slope is 2, so it's up 2, right 1, up 2, right 1. Here we want to write the equation of a line with a slope of 4 and a y-intercept of negative 7. So we've got m, and they gave us the intercept, so we have b. So we're putting this in slope-intercept form. So that means our equation is going to become y equals 4x minus 7. Question 2, same idea. We have our slope of negative 1/2 And our intercept, or b, is 9. So this is y equals negative 1/2 x plus 9. We want to write the equation of a line through the point negative 1, 5 and has a slope of 3. Well, to do this, we're going to go from point slope, and then I'm going to turn it into slope-intercept form. So remember, point slope is y minus y1 equals m times x minus x1. So that means we've got y minus 5 equals 3, x plus 1. So this is point slope form. If I want to turn it into slope-intercept form, I'll distribute my 3 for my slope. So I've got 3x, and then I'll add over the 5. So my final answer should be y equals 3x plus 8. In problem 2, very similarly, we're going to start with point slope form. And we're going to replace our values. So we've got y plus 4, because minus a negative is like adding the opposite. And then we've got negative 2/3 x minus 3. We'll go ahead and leave this in point slope form. But if we wanted to, we could distribute. If we distributed, just in case, say we wanted to, be negative 2/3 x minus 2 would be your slope-intercept form. This time we're given 2 points and they want us to write the equation of a line containing these points. The first thing we have to do is find the slope between the 2 points. So we use our slope formula. So we've got 5 minus a negative 1, so plus 1, over 3 minus a negative 2, so plus 2. So that gives us a slope of 6/5. Then we want to use, so we have our slope, we want to use one of our points, and I'm going to use 3, 5, and we're going to plug it into point slope form. So y minus y1 equals m times x minus x1. So that means we've got y minus 5 equals 6/5 times x minus 3. So that's point slope. And now I want to change it into slope-intercept form. To do that, I'll distribute the 6/5. So I've got 6/5 x minus, well, in this case we get 18/5 equals y minus 5. Then our last step would be to add over 5. And we're going to go ahead and turn this part into a decimal. So we've got y equals 6/5 x. We can leave it as a fraction. And it becomes plus 7/5. Oops. So our equation of a line is y equals 6/5 x plus 7/5. Here we're going to practice rewriting equations into slope-intercept form. Well, we've already talked about this, so all we're doing is distributing the slope. So 3x minus 12 equals y minus 5. Then you add over y1 essentially, and you get y equals 3x minus 7. This time we want to write this in slope-intercept form. Well, this one's a little bit trickier. We're going to get our y's on one side, everything else on the other. So to do that, I'm going to go ahead and let's say I subtract, let's just go ahead and subtract the 16x and the 4 to the other side, just so I can keep y on the left. So I've got 10y equals 2y minus 16x minus 4. I'll subtract 2y. I've got 8y equals negative 16x minus 4. And then I just need to divide by 8. And so I end up with y equals negative 2x minus 1/2. Here we want to find the horizontal and vertical equations for a line passing through the point 2, 4. Well, for a horizontal line, we know that we have a single value established, because if it's a horizontal line, the only value that really matters or doesn't change really is your y values. So when we write the equation, the x's aren't important because the x values change, but y is constant. So in this case, y equals 4 is your horizontal line. Then for vertical, the value that's truly important is the one that doesn't change. In this case, the y values change constantly, so the one that doesn't change is your x values. So vertical, we're looking at x equals 2, because no matter where we go on that vertical line, the x value will always be 2, but the y values will be ever changing. So for horizontal, you've got y equals a number. For vertical, you've got x equals a number. And so these are our two equations.